what is source control, and why am I forcing my students to use it? Well, source control is a tool that's used by software developers to keep track of changes to their code over time and to collaborate with others, and just generally manage your code during development with a variety of features. Some well-known source control solutions are TFS, Mercurial, Git, and Subversion. When using source control, all of your source code is stored on a server. You can pull down the repository of all of your code onto any machine, if the server is available on the network or online, and that makes moving around between different computers easy. When you make changes to your source code, you use the source control software to commit your changes and push all of your commits to the server. Any computer that has cloned the repository locally will be able to get the latest changes through a simple pull command. So as you're moving between different computers, all you have to do is use the pull command, and whatever your computer on will have the latest source code on it. The source control solution also keeps track of changes over time, so you can view all of the changes made to your code between commits, see who has changed what code, since it keeps track of who is updating what, and you can roll back your changes to any previous commit in the history of the repository. If multiple people are working with the same repository, you can work on the same code at the same time on your own machines. The source control solution includes tools that will auto-merge changes to the code, or if it can't figure it out itself, it has tools to help you manually merge your code easier. And if you want to have multiple versions of your source code, such as if you're working on a new version but you don't want to overwrite your version 1.0, you can make a branch. Each branch is separate, and you can easily pull code from any branch you need to switch between versions that you're working on. Source control is used in professional settings where software is being developed. It's used with open source projects, and if you're working solo, it is also useful for you, even if you might not be using the merge tools or other collaboration features. So here are some student nightmares. Have you ever made a change to a project and you broke something and you tried to revert it to the old version by maybe just undoing it or trying to find which code was new, but you just can't get it working again? I know when I was a student, there were a few times where I just completely erased my project and started over. That's a waste of time when you have an assignment due. How about, have you ever had your computer just die on you and then you lost all of your work? Well, that's where source control helps you out. So, Git is a source control solution. It is a software program that you run on your machine and on the repository server, and it provides commands like git add, git commit, and git push. So through these simple commands, you can manage your code and your changes. GitHub is a source hosting service. You can create a repository on GitHub, and they'll take care of the server stuff. You just have to clone the repository onto your own machine. GitHub is free to use for open source projects or otherwise public repositories. There are other source hosting websites out there. You might have been to SourceForge before, or you might have seen Codeplex, or maybe even Bitbucket or GitHub. Usually these are free if you're doing open source stuff, and maybe cost if you're doing something with a private repository. I use Bitbucket for any of my private repositories since it is free for as many repositories as you want, as long as your team size is 5 or less. 5 or fewer? Different hosts only support certain source control solutions, so for example, GitHub only does Git. Now, Bitbucket will do Git and Mercurial. So let's get started with GitHub. First, when you go to GitHub, you'll want to register an account. You can use a free plan, which provides free hosting for public repositories. After you register your account on GitHub and confirm your email address, your profile page will be at github.com/whatever your username is. So let's look at how to use GitHub from the web interface before we get into the command line. So first, let's create a new repository. From your profile page, go to the Repositories tab and click on New. Give your repository a name, or it has some randomly generated names you can use there. You can have a description if you want, keep it public, and also make sure to click initialize this repository with a README. That will put the first file in your repository for you. You don't have to worry about git ignore right now, and unless you want to actually make something licensed with like an open source license, there's no reason to really add a license either. So for example, you might add a class, a repository for your class. So data structures, class files. And then click on create repository. Now you'll have this interface for your repository. It'll be github.com, your username, and the repository name with dashes in between. You can also go back to it later by going to your repositories page, and whatever gets updated the most recent gets put on the top. So, now that we have this, let's look at how to upload code to our repository. So we can use GitHub totally through the web interface if we want. We will miss out on some features, but this is okay for, say, maybe if you're just getting started and it's an introductory programming class. So let's say I'm just going to make a source code file. This is my homework or whatever. And then I'm going to open this and add some stuff. So now I have a source file. If I want to back it up on my repository, I can click on Upload Files, and I can throw it in there. So I'm actually going to put this in a folder first. Let's say this is assignment 1. I'm going to throw it in there, and then I'm going to move the entire folder into this box. And then once it's uploaded, it shows what you have. If I have multiple source files, it'll upload multiple things at one time. And you can X out something if it just has some extra files that you didn't actually want. Now usually when you're making changes to your repository, you should add a commit message. This especially makes it easier to find what you've done. So uploading assignment 1 project. You don't have to worry about this stuff right now. Just go on and commit changes. It'll process for a little while. And now here my folder's been uploaded, and here's assignment 1. So likewise, let's say I have assignment 2, and I'm just going to have multiple source files. So let's just say this is blah, larg. So now I have multiple files in my assignment 2. I can upload files. Click and drag my assignment 2 up here. It's going to upload these, assignment 2, and commit changes. So now I have my assignment 2 files. And I can view these from the web interface as well. I can also edit these from the web interface. So if for some reason I wanted to change my source code here, I could, and we'll do that in a little bit. So you might want to create specific folders inside of your repository, and it's not going to let me upload an empty folder, I do not think. Yeah. Generally, Git will not store empty folders, so if you happen to want to make a folder, what you'll have to do is create a folder with a dummy file in it. Now you can create new files through the web interface, and if you want to make a folder, let's say this is my labs folder, and I'll hit the / button, and that will turn it into a folder. And now I'll just make a README and say this is a README. So the README is just kind of a dummy file so that the folder gets made. So now I have README inside of my labs folder. And let me go ahead and just rename this to lab 1. Once I'm inside the labs folder, I can upload my files. Commit. And now we have labs, and we have a lab 1 folder. We have all those. You could also go ahead and just create a new source file here. And if you wanted to take the source code from the text editor and paste it in, and then commit. So that will also work if you really want to. Okay, so Alright, so let's say that we want to make changes to an existing file. Now, if I wanted to get the latest from the repository, I'd have to go in here and copy it, or I can click on Edit, and Control-A to select all, and Control-V to paste. So that pastes that in there, and then I can keep working on this. This is not really the way it was intended to be used, but you can use this again if it's like an introductory programming class and you don't want to get deep into the command line interface. So let's just make some updates really quick. Okay, so I've made changes to this file. In order to update it in my repository, I'm just going to select everything and paste it back in, and add a commit message, added an age feature, and commit the changes. Now maybe if I decided that I wanted to not have the name feature in there, I'll go in there and make another change. I could just erase this part, and this is going to cause a build error, so I'm just going to do that. Removed name feature. So now it's just a really simple program, but look at this. We can click on history, and it will show me all of the different changes that were made. Here's the original upload. Here's adding an age feature. So if I click on this, it'll show me that these lines were added to the file. If I go back and click on remove name feature, it'll show me that these lines were removed from the file, and this line was changed, but it shows up as a removal and an add. So that can be useful for figuring out what's changed since your last commit. Also, if you're working with other people, you can click on blame, and it'll tell you who updated things at what time. So this was the original upload. That didn't get changed in the other updates. Here's the added age feature, and then removed name feature, and the very end of the program. From the main repository page, we can also click on commits. It will show us the list of all of the commits, not just for one file. So we can see that here's a README created. This one I didn't add a message to, but here's our main file, added age, removed name. And also, just as a note, anytime you have a README file in a folder, it will show up on the web interface main page. So if I click on README here and hit edit, I can change this around a little bit. This uses the markdown format, that's why it's MD. It doesn't have to be markdown, could be .text. So this is like data, structures, class. This is my projects for the class, and then you can do like a second heading, blah 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 blah. And I'm just going to commit. And now when I'm back on the main page of the repository, it shows any notes that I left there. Alright, so let's also look at this in terms of using the command line. So to use the command line, you'll need to download Git from gitscm.com. And you'll go to downloads, and you'll download, if you're on Windows, the Windows client, and whatever version you have, 64-bit Windows or 32-bit Windows. If you're in Linux, you can just go to your package manager and type in Git, and it will be in here. Once it's installed, in Windows you'll right-click on your file explorer and there will be a Git bash option. In Linux you can just go to your terminal. So this was the assignments that I were working on here, but this is separate, they're not linked together. I'm actually going to delete this for now, and we're going to actually clone it. Now first though, when you have Git installed, you'll want to set up your config. Your username and your email address is what's going to be associated with your commits. So if you don't set this up, this might show up like as a student account or whatever account is set up in the computer lab or whatever else. So that's the commands for doing that. Now, if we want to clone a repository, when we do that, it will pull the files down onto our hard drive and they'll be linked. All we have to do is use simple command line commands in order to push our changes to the web. Now, here, this is cloning the Doom repository from id Software. What you'll do is click on clone. I'm in my own repository right here. Click on clone. By default, I use SSH. There's a tutorial on GitHub for using SSH, but we'll use HTTPS right now. SSH requires a little bit more setup. So HTTPS, you click on the URL and copy it, and you go into whatever folder you want to have your files in, open the terminal or git bash here and type in git clone, and then you can paste in the URL, hit enter, and it will bring everything down. Now these are linked. Any changes I make here, I can easily just push them back to the server. So for example, let's go into assignment 1, and I'll make some changes to this. Oh, this is the age one. Let's add an extra feature. Float, money. So just a simple change. Now if I right click and open this folder in the terminal, I can type in git status, and it will tell me that this has been modified. Now, to actually add it to a commit or to a change set, I will need to use git add, and I can type in the file name, main.cpp, and if I do status again, it will show me that it is going to be committed, changes to be committed. So this is also in the slides if you want to view these on the class repository. So we've checked the status. When you go to commit it, you can type in git commit and it will open up a text editor. This one uses nano, but usually if you don't put a commit message, it'll abort. It won't let you do that. Usually I'll just type git commit -m for a message and put in my message here, because usually the messages don't need to be very descriptive, just something so that you can find it easily. So updated assignment 1, added money feature. Hit enter. The change has been committed. Now it's not updated on the web. We have not pushed it to the server. We've only made a commit locally. So we've created a commit, and we can make a bunch of commits before we actually push it to the server. So let's say you're working on a feature and you only want to push it once it's done, but you do want to make those backups in the form of commits while you're working on it. So you can make several commits while you're working on the file. So we can just add different stuff. We can add a second money thing, so it asks them twice, and that's really useful. So git add dot will add whatever files are in the current directory, which actually this added my executable file that got built, which we probably don't want to have in there. So I can remove that in a little bit. But that's why it's good to just say git add main.cpp if you're adding files. So I'll make another commit, added another money feature to assignment 1. Now, if you're working on multiple computers or if you're working with someone else, it's probably a good idea to do a pull before you do a push. So I pulled, it's already up to date. Now I'll go ahead and push my changes. Now, the default branch that gets created is called master, and it will ask me for my login information, and then it commits. Sometimes this might fail, so let me go ahead and go to the web interface. We'll see that this has been updated. So I'm going to do a couple things. I'm going to erase this feature here, locally on my machine, and I'm going to update it on the web. So this will be kind of like if someone else was working on the same project. So removed age. So now it's changed on the server, but my version still has age because I'm working locally. If I go ahead and add and commit this, and I try to push it, it's going to fail after I log in. So this is what a failure looks like, and it will tell you some messages. You just have to, actually read it and not freak out from all the text. So error, failed to push some refs, okay. Hint, updates were rejected because the remote contains work that you do not have locally. The remote being the code on the server. This is usually caused by another repository pushing the same ref. You may want to first integrate the remote changes, so it gives you a hint here. Use git pull, and then commit your changes again. So there are updates here, there are updates here, 2 different sets of updates. I'm going to pull the latest, and now I've had a merge conflict. Usually this isn't going to happen if you're working alone, but if you're working with someone else, there might be a merge conflict. And when I reload my file, it shows me where there was a merge conflict. It didn't know what to keep and what to remove, because on the web I removed age, over here I removed money, so you will just use these markers to see where you want to keep. Do I want to keep the original age, do I want to keep money, or do I want to get rid of both of them? So in this case I'm going to get rid of both of them because we both removed features and we don't want those in there anymore. So you might not have to worry about the merge conflicts. Git status, I'm going to add main and merged. I have to do another commit after I manually merge stuff, and now I should be able to push my changes to the master branch. So this has been updated successfully. When I refresh over here, it will have these changes. Now let's do a change that will not cause as many problems. I'm just going to say int a, b, c over here, and over here I'm just going to put something like this is a comment. So changing different portions of the code. Hopefully this does not end up giving us a merge conflict. So again, I'm going to commit my changes, added variables, and when I go to push, it's going to fail again. So again, it gives us the hint to try to pull latest changes. Git pull. It automatically merged this time, so it went to the text editor to add a merge message, commit message. Now I'm just going to exit the text editor. It's been committed, and I just have to push my changes again. And now it'll have the comment and the text. So if you're working alone, generally you don't have to worry about it too much. Just do the adds and commits and pushes. If you're working on multiple computers, you might have to pull here and there occasionally, but otherwise you should just be using those 3 commands and git status. And here's a tip for if the push fails. This is what we just went through, where it auto merged for us or it didn't auto merge for us, and then we have to commit the merge. So those are the basics of what you'll need to use Git from the command line. There are also other resources available if you want to use branching. So let me open this again. If I type in git branch, it'll show that I'm on the master branch, but I can have multiple branches and they can have different versions of the code. So get in the practice of using GitHub and Git, and you'll kind of wonder how you ever lived without it if you've ever spent time doing programming projects for school or on your own, and not having source control and all of the problems that leads to. So hopefully that will help.